Hello, I'm Padma Mallikarjunan. I am an enterprise support manager at AWS, and I'm based out of Austin, Texas. Welcome to AWS Supports You, where we share best practices and troubleshooting tips from AWS Support. In today's episode, AWS Supports You, leveraging AWS Identity and Access Management. Joining me today is Rob Iguereda from AWS Support. Can you give us a quick introduction, Rob?
Absolutely. Thanks, Padma. My name is Rob Higuerda, and I'm an enterprise support lead located in Austin, Texas as well, and excited to bring some new content to you today.
Thank you. Our topic today, AWS Identity and Access Management, or IAM Trust Relationships. We will specifically focus on using IAM roles for your cross-account access and also discuss using IAM roles across other AWS services. Before we get started, a quick note to our attendees online. Please use the chat window on the right-hand side of your screen to ask your questions and share your thoughts throughout the episode. We look forward to hearing from you. Rob, can you walk us through what we're going to be talking about today?
Absolutely. Thank you. So I'm going to share my screen here and go over some content with you all about how you can leverage identity and access management trust relationships for your AWS organizations. So today's agenda, we're going to cover essentially the benefits of just using an IAM role and trust relationships for getting access across accounts in your AWS accounts and organizations, and then using IAM roles as well and the benefits for access to other AWS services. So if you're new to AWS and Identity and Access Management in AWS, just a real quick brief on what it is, right? So IAM for us is an access management service that enables you to manage access to AWS services and resources securely. So you can give access to your AWS account to another account, to other users. You can give granular permissions to those users that come into your account. And you can also allow applications to make AWS API calls, so you can set your application up to be able to access your AWS services in your account programmatically. Helps you increase security by being able to leverage things like multi-factor authentication on your account, so you can set up your little hardware token or software token to give you another factor into your AWS account. You can also leverage identity and access management with federated access, meaning that you could leverage like your Okta or maybe your Microsoft Active Directory integration to access the AWS console and give access to your resources as well. And another nice thing about IAM is it's all audited in CloudTrail, so you can see the actions that are taking place in your account as well. This overall helps you with some different compliance requirements. Like I said, it's integrated into our services, so really easy to be able to manage those. And there's no additional charge for you to use identity and access management. There are a few components that we're going to be talking about today, and so I want to make sure that we cover those as well for anyone who's new to AWS Identity and Access Management. Primary one being a user. That's going to be what you're going to give an individual entity essentially access into your account, whether that be for a user that logs into the console and accesses, or whether you're using access keys or secret access keys to give access to your environment as well. With an IAM user, there's long-term credentials that go with it, and that might be a username and password, or those access keys and secret access keys. Those users can give permissions by themselves with a linear policy or added to a group, and those get kind of decided on cumulatively for those different policies that are assigned to whether it be the user or the group. And you can have up to 5,000 individual users in your single AWS account. So these aren't individual AWS accounts, right? These are just users that live inside of an AWS account that you're allowed to give permissions to. What we're going to focus on primarily today is going to be our IAM roles. So a role is an entity that can be assumed in your AWS account. So instead of having a user that you log in and give that user permissions to everything, instead we recommend that you create your users, have permissions that don't really exist so much on the user, and you leverage these roles that you assume into to get that. And you assign policies to these roles that help determine what permissions you're given access to. And those benefits to being able to use these roles is that you don't have a long-term credential assigned to these IAM roles. You have short-term credentials that get assumed and give access to your users. And then we also have an additional component that we're going to focus on today as well called a trust policy. And that helps us determine who can actually access that IAM role. So you have your user, you have your role, and then you have a trust policy or trust relationship that you assign. And those kind of cumulatively help you to give that granular access and permission into your AWS account. So I mentioned policies. So again, if you're new, probably need to understand what our policies look like and what they actually do. And the policies provide that authorization. So I mentioned they get cumulatively evaluated based on the user, group, role, permissions, and such. But really, you're going to define these on each one of the things that you're going to be limiting access to in your environment. And you're going to have specifications, and you're going to have enforcements that go with those. And you're going to define the access policy, and then you're going to have that evaluation of that policy that happens. You can kind of see here a little short blurb of what a policy looks like, and the fact that we say we're giving an allow. That allow action is given to S3 get and S3 list for all the resources. So when you define these access policies, you specify, which IAM principals are allowed to do things and what actions they're allowed to be doing within that account. So that's kind of a little bit on our policies. Before I move forward, Pam, I just want to check and see if there's any questions. Got a little bit more on policies, but I want to take a break here.
Thank you, Rob. A lot of good information. I do not see any questions posted online. Everyone, please post your questions here. Rob is our expert on this topic, and we are here to answer your questions for you. Rob, in the meantime, let me ask you a question. How can I shorten some of the IAM policies that I maintain to just make it easier for me to manage?
Yeah, so all the structure looks like what we have here in the little demo with the effect allow. And then you can see we have these actions that say S3 get, S3 list. And if you start to add those up per service, your policy can get a little long. We have two different statements that you can kind of leverage within your IAM policies to help shorten that. And one of them is going to be a not action and a not resource. So instead of having to give these individual items, you could say allow star not action delete S3 bucket or something like that. That way you don't have to list all the individual actions and not give them access to delete. You can just say they can have access to everything except for the ability to delete. Same thing goes for the not resource, where you could say they have access to all these buckets except for this specific resource to help you shorten those.
Got it. Thank you, Rob. And I'll share links to those policy elements on our chat window as well. Back to you.
Thanks. All right. So I mentioned we have policies. We have also a different variety of policy types that exist out there as well. At the organization's level, we have what we call service control policies, or SCPs. And those are going to be kind of your main policy that you can use on an organization to block anything from being assigned, even by roles inside of the accounts. So your SCP kind of just overall has that guardrail that's set for your organization. We have other ones for just the permission policies and permission boundaries that go with that. But specifically today, we're going to be looking at just the policies that go into your security token services, or your STS. And that just kind of reduced the general shared permissions further. And then our specific AWS service resource-based policies, it's really just looking at that cross-account access and saying account A can access account B. And we'll look to see kind of what that looks like in a demo as well. We also have VPC endpoint policies, so quite a few different variety of policies. The nice thing for each one of these different types, while there's many, they all use the same policy language. So what we saw before for that action, allow, and then the resources and such, they all follow the same structure, so you don't have to learn a new one for each and every different type of these. So why use roles and trust relationships, right? Why not just give my users access to my account or in each and every account? If you have a single AWS account, it may be easy for you to administer and manage that way. As you grow into AWS organizations and you start to follow kind of our multiple account strategy that we have for these, you'll see that we have a number of different accounts that get created. One might be for your security, where you have things like Security Hub and Guard Duty, and maybe your CloudTrail audit logs and stuff going there. Or you have a log archive account. Well, you're probably not going to want to create individual users in each one of these counts, because that way each one of your users has to have 10, 15 different usernames and passwords they have to remember, they have to change. You as an administrator have to assign permissions and policies to each one of those for each individual account, for each user. And it's a lot of additional overhead for you. It also means that if you have to remove access, you have to do it in all of the individual accounts instead of just one IAM user in your centralized kind of IAM account. So if we use roles, we can basically create a single IAM user in an account, and then we can say it has access to permissions to be able to assume into different accounts. So we can say, I have a user, my user account gets its user and password there. They log into that, and maybe that's using, as I mentioned before, a federated access through Active Directory. So they're really just using their Active Directory credentials to log into the console. And then they assume roles into things like a dev account, where they then have access to all the developer, area that they need for some of their infrastructure. And then they go back to their regular account, and then they switch back into the prod account where they have access to production environment. In between those with the different roles, maybe they have admin access in the dev account, and they can do everything and anything in that account because they need to be able to test different services, start and stop instances, do whatever. But maybe in production, they have a scope down set of permissions where they're only allowed to maybe, read some stuff, and other items are not allowed to launch services because they have to be tested first before they're whitelisted into being able to be used. And the other nice thing is that these don't come across the two. So we have this little red line kind of separating things that says, these don't actually have access across from account to account. You could allow that, but typically we'd see that, you'd want them to go back to their main user so they don't accidentally assume a role into production and do stuff that they're not supposed to be. So the trust relationship portion is a nice component that we allow that we can scope down who can actually use a role to a set of accounts, to a user, or to a role itself. And so our IAM role is going to define what the role can do. And it's going to be, as in this policy, it just says allow star and star, that we're giving access to everything for that account. It's an admin one. But we're saying only people in this trust relationship, those are the ones who can actually use this role is, users in account 99999 root, or the role people who actually can use this role / dev role in that account. They're ones that are allowed to actually go in and do those things. And to switch a role, we're going to see in the console here in our first demo, it's a pretty simple process. And that's what's really nice about it. And you can do it two different ways. Through the console here, where you're going to put in your account number or the account name that you've given to your account, and then your role name there as well. And you can define a color and such. We'll show you that as we go through the demo. Or you can leverage it programmatically if you have users that use the AWS CLI, where they can assume a role into an account from the CLI to do their typical actions. We've been working with AWS. Sometimes it's a lot easier to have a one-liner that you can usually run in your AWS CLI rather than clicking through the console. So it's a good benefit there. A nice continued thing about being able to leverage the roles themselves too is that you have Access Analyzer that's available in the Identity and Access Management dashboard. And what Access Analyzer is going to do is it's going to allow you to see the roles that you have in your account, the resources that they have access to, and then also show you in this next column here, right, the external accounts that have access to. And this way you can go through and you can see, what accounts have access to these roles. You can help to audit that in one central location to see, I can see all these different accounts that have access to my roles, what access level they actually have to it, when this role was last updated or accessed. It gives you a nice little view in order to be able to see this information. So definitely handy to have the Access Analyzer. One of the other benefits on why we recommend leveraging the roles over an individual user access for everything. And take a break here, Padma. I just want to double check to see if there's any questions from the audience.
Yes, Rob, we do have a couple of questions here from our audience. So let's go look at our first question. Our first question is from Yol1982. Thank you for your question. The question is, do you have a good list of all the AWS IAM actions? I will be posting a link here on our chat window that lists all our actions. And as you go through that, it will walk you through the general document of what a policy would look like. And there will be also some specific types of commands and elements you can use on a per AWS service basis. And that link that I'll share will point you to the specific AWS service that you can follow as well. Anything you want to add to that, Rob, before we move to the next question?
Nope, that's the best place to see all those lists of action. It's a long list. So yeah, definitely best to share it there to go through and review.
Perfect. So this next question for you, Rob, Thank you for your question, Tom A242. The question is, what do you mean by a group, the IAM group? Does this indicate a group of users?
Yes. So not covering a lot on groups today, but in IAM, we have users, groups, and roles. And so groups are, yes, you could assign users into a group, and you could assign permissions to those groups. Primary reason why we weren't covering it terribly today is you can't specify groups in a trust relationship across accounts. So you either use a user or another role. But yes, groups are just a combination of users.
Got it. So I'll also post a link to talk that describes all the different IAM identities, users versus groups versus roles for your reference. Please feel free to post more questions on the chat window. Rob, back to you.
All right, great. Thanks, Fatma. So just mentioning Access Analyzer to help. Mentioned a little bit about seeing how easy it is to switch roles once you have them set up in the console. And that's what I'm going to move to and demo next is going to be essentially just showing you how to leverage an IAM role in the console to be able to go through and do this. So I'm going to pull up a little demo here that we can show through here on how to leverage and do this in your AWS account. All right. So here we're going to be in the AWS Management Console, and we're going to see that I'm logged in as demo user at AWS Supports You demo. I am logged in as an IAM user at this point. So I've used my username and password to get into my console. And we're going to see here that in this account, I only have one IAM user because it's just a demo account. But this is where I would say create all the users from my organization or set up my identity provider from my other, say, Active Directory or something to tie into this. And that way, I'm not going to create users in all of my other accounts. I'm going to have my user accounts in here. I might have some roles in here that I can use to assign access to other roles in other accounts. But primarily, we can see that I've just got one user logged in here in these roles. I've made it easier on myself, and I've given myself my sign-in URL, like custom URL. You can customize your IAM login so that way when you go, you don't have to memorize your account number. For this one, I've just given it, AWS Supports You demo, and it just gives you that nice sign-in.aws or amazon.com/console link that you can use. I did that just to make it easier for the demo, and it's also just in general nice and easy for you to have a nice naming context to your accounts that you're going to be sharing roles into. So to switch roles, I'm just going to come into the console and check the switch role. And it's going to bring me into this area here. And so if I had named my account something that was easy to remember, I'd have to memorize the account number. If you're like me, I'm not going to memorize my account numbers if I have 10, 15 accounts and what they actually belong to. So instead, I gave it a nice short name for the account that I'm going to go into, and it's just called AWS Supports You IAM. The next column here is kind of important to remember. The role that you're going to try and assume, this is case sensitive, right? So you're going to have to either just copy and paste it from anything like I'm doing here because it's easy for me to copy and paste it. But if I were to type into this lowercase AWS SY IAM dash, capital ADMIN, I would get back an error because it doesn't actually follow the exact name that's in this other account. So just know if you're going through, we're going to post a link to a tutorial on how you can go through and do this yourself eventually. If you go in and you start just, typing in your role name and it gives you an error, go back and check case because it may be something that you missed there. For the different roles you assume, you can choose a color. So for this one, I'm just going to choose a different color here so that we can easily see when I switch roles into the account that I now have up in the upper right-hand corner, a blue area that says that I'm in a different account. We can also see on this screen in my identity and access management dashboard that I have 0 users in this account. So I'm not going to manage any usernames or passwords from this account. All I'm going to do is have roles that exist here. And so you can see in my other account, I had 51 roles. In this account, I have 76 roles, just roles that are created for different testing purposes and such. We can also see that the name is up there, this AWS Supports You IAM-admin at AWS Supports You IAM account. So I'm no longer logged in as demo user at my other account. With this one, I just have admin access to things, so I can bounce around and look at users, roles. I can come into the EC2 console here that I'm going to show and do anything in this account because I'm currently logged in as an administrator. So if I want to quickly launch an instance, I can jump through and come in and say Amazon Linux 2. I'm not going to configure anything because I'm immediately going to delete this instance. I'm just going to launch it, wait for it to say it's going to launch, and we'll just come into that console. Actually, I have to click the box here, and then we're going to click Terminate Instance. So we can see really easy, I was able to come into this account, switch into this role, launch an instance, and terminate it. Now, you also might be able to see how that's a bit of a problem, that you might not want all of your users to be able to do that in your organization. So I'm going to switch back into my IAM console, and then next, I'm going to create a role that has limited scope. Before I get into that, Padma, I just want to check to see if there's any questions from the audience before I go through kind of the next steps of things.
Yes, perfect timing. We do have a couple of questions here from our audience. For the first question, thank you, Tushar, for your question. So the question is, what does root mean in a policy principle ARN? So I'm going to post a quick link here that walks you through what an AWS account root user is. So Rob, do you want to add anything more on the root user?
I'll actually show you here in just a little bit, because I'm going to edit my trust policy, because yes, that's something we may want to scope down a little bit, but I'll definitely cover that, because we're definitely going to show what that looks like to have that, what it actually means to have root in there.
Perfect. Yep. So in Rob's demo, you'll be able to see that when you create an AWS account, you begin with that single sign-in identity, which gives you initial access to all services and resources in that account. And Rob will walk you through that. And I'll also share a link about best practices that are associated with AWS root users. Okay, so I have another question here. Mm-hmm. This question is about using tags in our policies. So thank you for your question, more type TRB. The question is it possible to give access to resources based on specific tags?
Yeah, so we actually recently announced or recently released access-based access controls that leverage tags in order to be able to assign access to permissions. So that's another way that you can kind of also additionally help to scope down some of your policies, like the number of policies you have, because you can do things based on tagging as well. There is some good documentation out there that we can provide as well that goes over access-based access control and how to use tags to give permissions to things.
Perfect. I'll post a link to tag-based access controls here, and it'll also walk you through the list of services and some examples on how you can use tag-based access controls. Another question here. Thank you, Tommy242, for your follow-up question. So the question is, can I define access by AWS region? So before I turn this to Rob, I will post a link to an AWS blog that walks you through how you can easily control access to AWS regions using IAM policies. For example, you can specify the region to which your IAM principal, like a user or a role, can make API calls, for example. Rob, anything else you want to add to that question?
No, yeah. The conditions that you have on IAM policies, you can specify a lot of different conditions, and there's a list of those that are in the documentation as well. But yeah, from region. Additionally, using the service control policies in AWS organizations will allow you to kind of help limit some of the access as well. So you can use those as your guardrails for limiting where your users can do things at.
Right. Thank you. And all great questions. Keep the questions coming in. Back to you, Rob.
All right. So as I mentioned, right, having everyone be able to assume this admin role that can do anything in your account might not be the best practice that you want to follow, because they'd be able to launch instances, terminate them, do whatever. So what we can do is we can create these different roles and we can scope them down. So when we go into the console, we click create role and we get a few options here. We can say allow access to an AWS service that we'll talk about a little bit later, access to another AWS account, to a web identity, or to a SAML 2.0 federation. And that could be like your Active Directory, or if you use Cognito or an open ID provider, you can allow access to those as well here. For today's demo, we're going to be looking at just another AWS account. So we're going to let my AWS demo account access my IAM account here. And that's how we're going to specify kind of allowing access across. So when I do this and I click another AWS account, I do have to have that other account number. And I'm going to put that other account number into this to say, this account ID has access to my account. We're not going to use this require external ID today in this demo, because we're actually using it in the console. But the require external ID is great if you're going to have a third party that's going to be leveraging your account and you want to make sure that it's actually them. You can provide not only the account and the role that they can assume into, but have to provide a specific external ID that's kind of a little, third bit of knowledge that they have to have other than your account name and the role that you're going to assume. And this is basically just used so that you can make sure that, you don't have somebody accidentally assuming a role that they should be programmatically into your account by leveraging this. As I mentioned, this isn't really supported in the console, so we're not going to use it today since this demo shows you just kind of easily through the console how to do it. But if you were going to be doing things through the CLI or through another programmatic method, you could enable that. Not going to enable MFA today, just so I don't have to type in the token while we're going through the demo, but definitely wherever you can, we recommend using MFA. So definitely get that set up on your account, not only for root, but for your other access to accounts, especially privileged ones. Once we start to create our role, we have to choose what permissions it has. So say this role is going to be used by your IT operations center, and all they need to do is be able to correlate, say, errors that show up from their monitoring system into the actual EC2 instances, or they need to be able to go in and check CloudWatch metrics for individual EC2 instances, maybe validate some information in an auto-scaling group or on an elastic load balancer. So you're going to scope down the level of access they have to only EC2 read only. And that's going to just say that they only have access to that policy. If you're seeing here, there's a bunch of different policies that exist. And a lot of these policies are all AWS managed policies. So they're not policies that were created by a user. The ones that AWS has predefined for you to be able to use that should give you access to those things that it says and will tell you. So you can add tags to this as well. But for today, we're just going to give a name of this tag. And we're just going to name this one for AWS Supports You, IAM EC2 read. And then we're just going to give a little description to this that says, hey, it's used for read-only access to EC2. We can see that I've specified the account that's going to have access to it. So that's my trusted entity that goes in my trust relationship. And then we see the policy that I've assigned to this role, which is just Amazon EC2 read-only access. So that's all they have access to. We're going to go ahead and click on Create Role. And that's going to finish my create process. And we can see that it exists there. And I have the role ARN. So this role ARN is going to be something that you're going to need to provide to a user. If they were using this to assume a role from the CLI, they're going to need that ARN to put in order to be able to do that assumption. You can see if I have my role description, the path, last activity. Since I just created this, obviously it doesn't have any activity. You can provide your user with that link that users can use to access that role directly. So if they just want to bookmark that role, they can bookmark that role and it will take them directly in as long as they're signed into an IAM user, an account that has access to assume that role. We can see the policy that's there, and we can go into our trust relationship. And we can see in the trust relationship that we've got a trusted entity of this account and the account number. So this is where we're going to specifically go in and we'll take a look at what I mentioned before is giving root access to this, right? So we see we've got our policy, and my policy says that I have an allow to this AWS ARN of ARN AWS IAM 68175 account :root. And it says this is allowed to assume role. Now, when I put root in there, that basically means everything in that account can access this role. And so that's where you may want to change this overall so that you're not giving an entire account access to this role. Maybe you only want to allow another role from that account access. So first within that role, your user logs in and they have to assume, say, their dev role. And now the dev role is actually given access to this one to be able to do things. Or a user logs in and they assume a role into the IT operations role that they have in your original IAM count. And then they use that to access this. And this allows us, again, to make sure that your actual user principals that exist in IAM have no permissions assigned to them other than to be able to assume roles. And that way you don't have to worry about individual users having policies that you have to administer and manage, and everything is done through a role. If you wanted to, say, only allow a specific user, you can do the same thing, and we would just change this from role to user/username. And that would basically scope it. So only the user that is in that 68175 account could access this role. So definitely something you'd want to take a look at. You may not want to allow your entire other account access here. You may just want specific roles to be able to, helps you get a little bit more granular in your permissions. You always want to practice write least permissions where you can, so definitely take advantage of using this feature as well in the trust relationship. Again, we have our conditions here that we were just really quickly touching on. There's a long list of conditions that you can put into here, whether it be they can only assign this role from a specific IP space or based on the region that the call is coming from, different items that you can kind of throw into IAM policy conditions, long list and the long list on which ones work with which, but that's all in the documentation as well. So we're not going to add any conditions. We're just going to leave it back to the root of this one. So my account can just access this. And now we see that I've got my new role created. We've got some other options that are available on roles as well. Access Advisor is a nice one where we can see again, like we saw on overall roles, what roles had access or what accounts had access to assumed roles. In Access Advisor, we can take a look and see what this role has access to. So we can see this has access to Amazon EC2 autoscaling, CloudWatch, Amazon EC2, and Elastic Load Balancing as well. Since we haven't used this role, this last access is not there. Another nice thing about roles that we have availability to is we're going to take a look at is this revoke session as well. And the revoke session is basically a way that you can revoke all temporary credentials that exist for a role. Say someone was in your IT operations center and they moved teams from the IT operations center and they should no longer have access to this role, or they've left the company and you want to make sure that everyone that has access to this role currently is authorized users. You can click this revoke action section, active sessions button, and it will attach a policy that will basically revoke all temporary credentials for people that have those roles assumed and basically essentially make them re-authenticate. That way you can validate they have an actual valid IAM user and such. Great way if you ever have even you're using it and you have a user that has their access keys compromised, you could use this to revoke sessions to make sure that anyone that had their access keys compromised, you've rotated their keys. You want to make sure that they have a valid session that's with a proper authentication. You could use this to revoke active sessions as well there. So kind of another nice feature that's built into roles that you can leverage to help keep your environment a little bit more secure. So now we're basically going to go back. We've seen everything that we have in permissions, trust relationships, Access Advisor, ability to revoke sessions and such. And we're going to end up looking to see what happens if we go and use this role in our account, since we now just have our EC2 read-only access to it. So I'm going to switch back into my demo user account that I have that's not in this account. So I'm going to go back to demo user. And I'm going to assume a role back into my other account using that EC2 read-only role here. So let me switch back. Again, I'm going to put in my account name to copy and paste my role name so I have the case correct on this one, and put this into my role name field. And I'm going to choose a different color just for illustrative purposes that we're in a different role. We can see that now I'm in this AWS Supports You EC2 read role at this account. And even if I try, say I'm in Identity and Access Management here, if I try and go to the dashboard for Identity and Access Management, I don't have access to do all the things that I did with my other account. Therefore, it gives me some errors. Same as if I try and come into EC2 and I see the instances that are running, and I've got this instance that we're going to use later for our demo. If I try and terminate this, it gives me an error and says, no, you're not allowed to terminate this instance. And that's because, right, as we gave this one EC2 read only, we only want that IT operations center to be able to come in and look at the EC2 instances. Tell me, is it in running state? Have any of my health checks passed? All my CloudWatch monitoring metrics, coming in? Am I seeing anything that's going on for that instance at all? And use that. So that's all I have for the demo for that one right now, Padma. So I'll go back to you to see if we have any questions from the audience as well.
Thank you, Rob. Yes, we did have a couple of questions that came in right during the last few minutes of your demo. So related to that, question from Tushar5. Thank you again for your question. Would all roles and users in an account be allowed to assume the role?
So that depends on your trust policy and that trust relationship that you define. So you would want to scope that to how you actually want that role to be used and who you want it to be used by. So as we kind of looked at the demo where you had the whole entire role arm that was allowed and said root, That's the part that you would change so that not everyone can use that role. So you can scope it down and say only role/role name can use it.
Got it. And this next question also related to the last part of your demo. The question is from RayDB222. Thank you for your question. Can I remove permissions that I don't really need?
You should. So we always recommend starting with least permissions, right? So, or least privilege on your IAM policies. So as you define the different roles, you're going to want to make sure you understand what you're really allowing them access to and make sure that you have those set up. And you can customize your actual JSON, the policy itself. So as I showed, we have a bunch of AWS managed policies, but in realism, right, you can go through it and you can either use those as they are, or you can use them as a base for kind of your own use case where you say, yes, I want people to be able to use this EC2 read only, but I actually want to scope it down if they can't see auto scaling. You might just start by copying the existing JSON and then going and pasting that into your own policy and configuring it to what you want to do. So you can either use the managed ones or create your own custom.
Thanks for that, Rob. And everyone, please keep those questions coming in. We are here to answer those for you. And back to you, Rob.
All right. So as I was mentioning originally, we have the users and those have access keys and secret access keys. And it's actually kind of one of the reasons why we recommend that you use roles so you don't have those long-lived access keys. If you're in an organization that currently uses those access keys and secret access keys, you can leverage AWS Trusted Advisor to find aged access keys. And so that's just what I wanted to show here real quick, was that basically in the AWS Trusted Advisor, you can do a check under the security, and it's going to tell you the access keys that are long-lived and the reason for why they're being flagged. Is it green or yellow or red? So as we can see here, our recommendation is every 90 days, you should be rotating those keys. You're not alone. If you're out there, you have more than 90 days, you have 2 years worth of access keys that are out there that haven't been rotated. Sometimes if you work with vendors, it's really hard to get those keys rotated. But if you have that case and you're not sure the age of those, you can take advantage of Trusted Advisor to be able to find those aged access keys so that you can maybe start your process of converting users from user access keys to roles. And there's some additional tools that you can use as well with the CLI to help you manage those profiles and really make it really easy for you to be able to leverage the roles from the CLI rather than embedding your access keys. So we're going to switch gears just a little bit. We talked about how you can use from your account itself, from one account to another account, to access an AWS account. But maybe you're inside of your account and you've got your EC2 instances that need access to S3, to DynamoDB, to RDS, whatever other service they're going to need access to, right? And we want to be able to not have to embed access keys. So one way you can do that to allow access programmatically from an EC2 instance to something like Simple Storage Service or S3, you can embed an access key into your application. So you would create a IAM user, you would create a set of access key and secret access keys, and you would embed that into your application to be able to make calls to things like S3 or MySQL. Benefits to it, right? Set it and forget it. You create that user key and password or secret access key, you embed it in your application, you never rotate the credential, it just always works and has access to it. But that's also the downfall to it. You have those long-lived credentials where if someone is working on the code that this key is embedded into and they accidentally publish it to like a public Git repo, they store it on their laptop and their laptops get stolen. Now somebody has access to that access key in the application and can do different things. You have to manually go in and actually rotate those keys if you embed them, right, as a better practice. So it kind of, has a bigger risk of inadvertent exposure there overall with it. Or you can leverage, much like we did with a user and going across account to a role, leveraging an AWS IAM role on an EC2 instance that will give you access to S3 via that IAM role. And this does the same thing, much like we saw in the actual CLI sample, where a user says, I'm going to assume a role and get a temporary set of token credentials. And those token credentials are going to say, I have access to, put resource in S3, whether it be create bucket, say they just have access to everything in S3 because an application you wrote does image stores, and per user, it needs to be able to create a bucket, upload images for that user and kind of categorize those. It also needs access to MySQL to store their information about what they put into S3 and such. And so the nice advantages to being able to leverage this is you have automated token access. So it just uses an identity metadata service that exists on EC2 to assume basically that role, get its temporary credentials, and then use that to access your application. So those tokens are short-lived, so you don't have to worry about manually going in and rotating access keys. You also don't have to worry about these being embedded into your application and having an accidental or inadvertent key exposure from publishing it to a Git repo. So those are kind of the advantages of being able to use an EC2 instance with an IAM role to be able to grant access to S3 and MySQL. I'm going to pause real quickly there, Padma, just to see if we have any questions.
Hi, Rob. Thank you for that. We have one question here from Ren Corbro. Thank you for your question. The question is, how do you provide cross-account access to an KMS encrypted S3 bucket from a different account? I will share a list here, a documentation here that gives you and walks you through description and walks you through the best practices of how you can enable that. Rob, do you want to talk through that?
I don't honestly remember exactly how to do that, so the documentation probably could be the best way to refresh on how to do that. So.
Got it. Yeah, the documentation walks you through a step-by-step way to set this up. So you can grant access to an AWS KMS encrypted bucket in an account A to another user on account B. Let me share that with you on the chat window. And everyone, please let me know if you have any other questions here for Rob. So Rob, do you want to tell us a little bit more about using IAM roles on an EC2 instance?
Yeah, so I'm going to show really quickly here. I'll kind of just demo what it looks like in order to be able to use an EC2 instance with a role in order to give access to AWS resources here. So I had my demo instance that I have running in my account, and it's just called my AWS Supports You S3 instance. And I'm going to leverage, right now I just have a role, an IAM role that gives me access to leverage the SSM agent on this instance to get access to the console. So not a lot of permissions to this thing. It's just called Amazon SSM role for instance quick setup. Just a little plug for that. If you're not using the SSM role, for instance, like getting into your instances, it's a really nice way to be able to leverage it without having to allow SSH or RDP into your instances. You can just use the SSM agent to get in. And I'll show you what that looks like. But if you were to create an EC2 instance, in order to attach a role when you create one, you have the option to add a role to it. And that role gives it permissions onto what it can actually do in your account, whether it's be that you're allowed to access it for SSM. So you're saying SSM can access this instance, or I have another IAM policy that I'm going to assign eventually to this that'll be part of the demo as well. But when you launch your instance, you can assign an IAM role to it. After you launch it, you can go back and do the same thing. So as I mentioned here, I have this instance quick setup role that's assigned to it that just lets me use the SSM agent. So here I'm just going to click from within my browser and be redirected to my terminal, which I love for SSM. So let me do that to get in. And now say I try and do something in EC2 just to describe the volumes that I have in EC2. We can see that because my IAM policy only has access to allow me SSM, basically to use the agent, I get denied. So we can see it's because I have this role here. And so even if I launch it, I'll show you what that looks like. We just have SSM managed instance core. And this is just going to give us very limited permissions. We can leverage that access advisor that we looked at before to see what exactly it gives me access to, right? We can see that it doesn't specify anything for EC2. And that's why I got the error message that essentially says, sorry, you can't actually launch or describe your volumes in EC2. I could attach additional policies to this one, but I'm going to use my other policy or other role that I created. And the nice thing, like I said, is you can switch your instances roles after they've been launched so you can change the access to them. I'm going to come into security and I'm going to say modify my IAM role. And I already have a pre-created role, this AWS Supports You EC2 read. And I'm going to switch that one and click save. And now when I go back to my instance, I can see, I've got to refresh this really quick. Before I had this instance assigned to it or this role. And now I have a new role assigned to it. That's my AWS Supports You EC2 read role. And if I go back to my console and I do the same thing that I just tried to do with describe volumes, we'll see that now I have access to EC2 to be able to do things. Didn't have to reboot my instance, didn't have to embed user credentials or anything like that into it. Just by assigning the role permissions, I was able to now describe my volumes that I have in EC2. So you may use it for something as simple as administration, but really you can use it programmatically for things like S3. So if I wanted to create an S3 bucket, obviously the permissions that I assigned so far were EC2 read. So I'm not going to be able to actually do anything, or should not be able to, right, based on what we looked at. So if I try and hit the S3 API and say create bucket, again, I'm going to get expected access denied because I haven't actually allowed access into that. But say I just want to use this policy. Obviously, you want to update the name of it to something that made more sense or create a separate policy for this. Quickly for today, I'm just going to attach another policy to this. You mentioned before, could I limit permissions that are in a policy? For this one, like I could choose the Amazon S3 full access or read-only access, or I can create a policy on my own and specify my own policy actions. So if I click on create policy, I'm brought to the visual editor. If you have existing JSON documents for your policies, you could do this in the JSON editor. If you're like me, when you're creating policies, sometimes you just like the additional peace of mind of using the visual editor. This is our visual editor where you can choose a service, add information, say I'm going to do S3, say we only need to allow access to write for this because we're just going to use all these actions to put items, create jobs, whatever. We could just limit it if we wanted to and say all they can do is create bucket, maybe delete bucket, or maybe we don't want them to be able to delete bucket and just create bucket so no one ever gets rid of stuff. You can have them put objects. So we can say this EC2 instance can create a bucket and put objects in that bucket. And so that's how you can remove permissions or start from that least privilege that we were talking about before a little bit, and kind of help you to not have to use the AWS managed policies if you don't want to, and you can define exactly what you want for permissions. For today, I'm just going to go back and use our AWS S3 full access. I'm going to cancel this and just say, go back to my S3 full access policy and attach that policy to this role as well, just to illustrate, how we can use an EC2 instance to do this. So now I have 3 policies attached to this one role, my S3 full access, my EC2 read only, and my SSM, so I can continue to access my instance for the SSM console. But when we go back over into my instance, again, I don't have to reboot. I don't have to do anything. My role already exists on there. I've already changed it to this AWS Supports You EC2 read role, and we're all set there. That now when I try and create a bucket, we can see that my bucket creates successfully. I don't get any errors back. And so that's kind of how you can leverage an AWS EC2 instance with a role in order to be able to give it access to do things with AWS services without having to embed the access keys into your application or anything, and help you kind of keep your environment a little bit more secure with those short-lived access credentials. So back to you, Padma, to see if we have any questions about any of that, leveraging the EC2 instances and roles.
No further questions on the chat window. Thank you for sharing all that information with us today, Rob. Everyone, today we looked at IAM Trust Relationships with a focus on cross-account access and using the roles across other AWS services. If there are any questions that were not answered today, please post them on forums.aws.amazon.com and email us any feedback, awssupportsyou@amazon.com. We want to hear from you and tell us what else you would like to see on this show. And also a special thank you to our moderators for posting the registration page for our upcoming episodes, awssupportsyou.splashthat.com. Please bookmark this page, and we hope you can join us next time. Thank you for joining us today at AWS Supports You, and happy cloud computing.
Happy cloud computing, everyone.